helicopter activity. First thing we're going to do is measure the height of the door, because that is what we're going to keep as a controlled variable. 7 feet. Let me get my stopwatch ready here. First experiment is Model A. To keep everything consistent, the top of the door is always going to be the rotor. Go. Okay, that took 1/4 of a second. Okay, our next experiment is going to be with the second model, which is Model B. Model B had shorter rotors compared to the base. No weights. 1.8. Last one is Model C. We're off. I didn't even see it if it turned or not. So that is going to be 1.78. Okay, so that was just the model. There was no weight on each of the models. So the next thing I'm going to do is I am going to attach one paper clip to each of the models to compare the weights of the paper clip to just the model without any weight. All right, here we go. One paper clip, and these are not jumbo paper clips, they're standard sizes. And we're off. So that is going to be 2.2, so just a little faster. This is Model B. And that was a mistrial, so I have to do 1.53. Okay, so this is Model C, but what I noticed about this model, and I don't know if it's going to be a contributing factor or not, but it does have a long base, but I did not count the entire base because the instructions said to fold it up. And I'm sure the reason that we had folded up the last part of the base was to already give it some weight so that our rotors will catch the air so they would twirl. But I'm going to add another paper clip. Here we go. 1.88 seconds. Last round. So the last round is going to be no paper clips, but what I'm going to do is I am going to adjust these propellers or the rotors. So what I'm going to do is I'm going to flip up just a portion of each of the rotors to see if that does anything from the time that it's dropped to the time it hits the ground. Model A, no weight, as in no paper clip. Rotors are tilted up, we're off. So that was 1.76. All right, here we go with Model B. Remember, Model B had the shortest percentage of rotor length to base length. No weight, and we're off. 1.51 seconds. Model C. 2.11 seconds. The next thing I'm going to do is I'm going to add one paper clip to each of these. First one is going to be Model A with the rotors tipped up with one paper clip. 1.95 seconds. Model B, rotors tilted up, one paper clip. 1.3 seconds. And finally, Model C, rotor tilted up, one paper clip. Let me reset my clock and go. 1.55. Okay, so kind of to wrap things up, I feel like my experiments with the conclusions were kind of in line with what I had predicted that would happen. However, in a minute, I'd like to talk about something that's counterintuitive with students, and we'll get to that in a second. But first of all, this was my Model A, and it had the longest rotor percentage in relation to the base of the stem. And that actually stayed afloat the longest without any weight. And it also stayed afloat longer before I started bending the tabs to see what would happen with the rotors being bent. Also with Model C was the next one that stayed afloat the longest. And again, if you notice the length of the rotor in position to the base, it kind of makes sense, and it kind of goes along with the longer the rotor in relation to the base, the longer it's going to stay afloat. So it would be really interesting. I think I'm going to try to find this on the internet, maybe tag it on the end. What are the specs for an actual helicopter in relation to the actual carriage that carries the passengers? How long should those rotors be? Is there a certain distance to determine it's safe to fly? Also, back to the counterintuitive part. Usually when we're dealing with distance, time, speed, things like that, students are always assuming, or not always, most students assume that the quickest is the answer and is the best choice. But in this feature, do you want your helicopter to stay afloat the longest to ensure safety of a nice, easy landing for whatever the cargo is? So that is something to be considered, and I would like to have that as some sort of extension question, maybe to follow up and further enrich this activity.